Let me start recording. So, good morning, everyone. So, here is the link for the attendance. Please fill the attendance link. It's in the chat box. Okay. Last time we starting for real numbers, and we left small things in the real numbers. So here is the link. Here is I cannot see the link. Here is the link, Brandon. So we left the sets. We started talking about the sets and interval, and I left small things over there. Intervals, sets and intervals. Okay. So let me remind you for the notation about intervals. So suppose I have a table look like this: 1, 2, 3, 4, 5, 6. Here is 6 tables. One, 2, 3, 4, 5, 6. Okay. And I need one more line. So here is the first things here review from last time. So here is the notation. Here is called the set description. And here is the graph of the interval. So suppose I have notation look like this: open interval a comma b. This is mean, like I said last time, is all values x such that x between a and b, and such that a and b are not including inside this interval. Why? Because the endpoint are not including. This is open interval. The graph for this one is like this: open circle at a and b, open circle at a and b, and there is a line between a and b. So here is open circle at a and b like this. This is a, and this is b. And here is a line between over a and b. So I means all values between a and b without endpoints. I mean for the endpoint a and b themselves. For the second notation, for the second one is the closed interval a comma b. So last time I said for this one is all values starting from all values start from a, and a is including to the point b, and also b including. So a and b, both of them are endpoints, and they are including inside the interval because we have closed interval. So the graph for this one look like this. So we have a closed circle at a and b, both of them. So at a is closed, closed. This is b. The third one is open and closed. So I suppose I have a comma b, and at b is closed and at a is open. So the interval description is look like this: x such that x between A and at A not equal, but at B is equal. So the graph for this one, we have open circle at A and the closed circle at B, and there is a line between A and B. So here is open, here is B is closed, this is A, this is B, and there is a line between A and B. Third one is from A to infinity. Infinity is a large number. The description for this one is x such that all values starting from A to infinity positive. So from the smallest number goes up to the infinity like this. So I mean for this one is all values from A to infinity like this. So open circle at A, open circle, and small arrows goes to infinity like this. Goes to infinity. Third one, for fifth one is minus infinity to infinity. I mean, before this one, sorry, before this one, we have another one from minus infinity to B is closed. B and is closed here. So I mean, for all values, x such that x is less than or equal B. Why equal? Because it's closed at B. So be the same like the previous one, the graph will be same like the previous, but at B have a closed circle and all values goes to minus infinity like this, minus infinity, and we have to know is a closed circle at B. Last one is from minus infinity comma infinity. So I mean for this one, all values x such that x belong to the real numbers. All real numbers are in this interval. So the graph like this graph is all values, all line. Have small arrow here and same things here. So all values here. Any question for this? Do you have a question?
No.
Okay, let's give me, if no question, let me give you a small example how to use the union between starting from the sets, then I'm going to the intervals. So the last one, what set description says all values such that x belong to the real number. I mean for this one, all real numbers are describing this open interval. From minus infinity to infinity means all real numbers. X such that x belongs to the real number. Eric. Okay. What will be direction for the last graph? The direction is from here to this. This is the direction. Like arrows, red one for all line with this direction. Clear? No, just one way, not both way, only one way. This side.
Wait, so the only positive?
Yes. I don't know why, but this is like, we have to know it's a line for all real numbers with way for the head of the arrow in this side.
Okay.
Okay?
Yeah.
Okay. So example, if I have example, if s equal, for example, 1, 2, 3, 4, 5, up to 5, only 5, and I have another set t equal 4, 5, 6, 7, and the last one is v is 6, 7, 8, 6, 7, 8. And the question is, number one, find S union T. So for S union T means the set that have all element of S or element of T or element of both of them, S and T. So to do this one, I have to write all element in S, 1, comma 2, comma 3, comma 4, comma 5, and I have to put the element of T. So 4, we will write it already. We don't have to write it again. 5, we write it already from the set S. 6, we have to write it down here because it's not written already. 6 and 7. Now, the other set, yes, go ahead.
You don't include 8?
8, no, it's T.
All
T
right.
doesn't have 8. It has 4, 5, 6, 7 only. No 8 inside T. So we're only looking for S and we're looking for T only.
Oh, sorry. Yeah, the
Yes, and this is V.
Right, right.
Okay, this is V here. This is T.
So this is a sign. It says find S, and then there's a sign in the between S and T.
Union. This is union. This sign means union. S union T. Okay. This sign here means union. S union T means all element in S or all element in T or all element in S, both of S and T. So first thing you have to write down to do this one, write down all element in S, 1, 2, 3, 4, 5. Then you have to write down the element of T. So 5, 4, we write it already from S is here. We don't have to write it again. 5, the same things. 6, we have to write it down because it's not in the set, and 7. Now for the set S intersect T. This is mean the element, the common element between the both of the set S and T, the common element between of the both sets S and T. So we're looking for the common element. You're looking for 1 is not in T, 1 is not in T, 2 is not in T, and 3 is not. 4, yes, number 4, because 4 is in S and is in T. 5, yes, is in S and in T. So 4 and 5. Any question? Last one is S intersect V. What is the common element between the set S and the set V? Who will do this one?
7. There is no.
6 and 7. Sorry.
6 and
Actually, I'm
7.
sorry. I was looking at T and V. I'm sorry.
No,
Not
S and V. S and V. This
is
one and this one
is an empty set.
is empty set, exactly. So we don't have anything. So here is open set. It doesn't have any element because one is not common between both of set. Two the same things. Three, 4, and 5. So there is no common element between the set S and the set V. So it will be like empty set. It's donated like this, or we can donate it like has a notation like this. This is mean empty set. The set does not have any set does not have any element. Set without any element. Okay, this is clear. This is for sets. Now let's do it for intervals. So my second example, I'm going to the next slide. Okay, so the example now, graph the set, the open interval from 1 to 3 intersect the closed interval from 2 to 7. Okay, I'm going to do this one step by step. So first things you have to write down, you have to graph this interval from 1 to 3. So write it down, 1, 3, the open interval. So as we know, the graph for this one from the previous slide, something like this, the first notation. A, the open interval from A to B, the graph has something like this. Here, the graph will be like this. We need the graph for this interval, and we need the graph for the second interval, and we need the graph for the result. Here's the graph for the result. So the graph for the first one from 1 to 3, we have open circle at 1. So this is suppose my 1 here, and this is 3. And we have a line between 1 and 3, like this. So this is 1 here, this is 3. For my second interval is a close from 2 to 7. So the number 2 will be like in the middle between 1 and 3, right? Number 2, this one, will be in the middle between 1 and 3. So it would be something like this here. And because it's a closed interval, would be like closed circle, like this. So here is number 2. And the 7 is greater than 3. So the 7 will be like around here, approximating around like here, this point. And again, because it's a closed interval, we have to close it. It's a closed circle. So this is number 7. Now for the question is 1, 3, the open interval 1, 3. Let me use different color. I'm going to use the blue one. 1, 3, intersect close interval 2, 7. So we're looking for the common numbers between the first set and the second set. So as we look into the graph in the first one and the graph in the second one, this one, the closed interval, we see the common between this two interval is starting from 2 and going more to the right up to number 3, and the 3 is not common between the two intervals. Is not common between the two intervals. So the graph for this one is look like this. So at 2 is common between the two intervals. So at 2 will be like closed interval like this. Here is number 2. And if we're moving to the right, we see all this element here is common between the two, but the 3 is not common because here is open and here is closed. So it will be like open. And here we have to write 3. So the answer is from 2 to 3. At 2 is closed and at 3 is open. So the answer is equal close at 2 and open at 3. This is the answer. Any question?
I have
So
a
we
question.
just
Yes.
include 2 and not include 3.
Not including 3, no.
Right.
Okay, I get a question here. I don't understand. Okay, let me do it again, explain it again, I mean. So the interval from 1 to 3, I explained this before, from 1 to 3. And the interval from 2 to the 7 is a closed circle at 2, closed circle at 7. And we have to know it's from 1 to 3 is there. So the 2 will be like in the middle between the 1 and 3. And the 7 is greater than 3, so the 7 will be here. Now the question asks, what's the intersecting between two interval? So the intersecting between both of them, we're looking for the common between the two lines. So if we're looking here, starting from here, there is no common element between this line until number 2. Number 2 is a common between the two line. Then if we're moving to the right, we keep moving. We see stop up to here, number 3. So the 3 is not common because here is open circle, here is a closed circle actually. So the interval will be, the intersect is from 2 because the 2 is common between the two line up to 3. We're now moving to the right more because here we stop for 3. So here is no common between the two lines. So the value is from 2 to 3. Open circle at 3 because there is no common between both of them. And a closed circle as 2 because the 2 is common between this line because we have 2 here, we have 2 here. So it's closed.
I have a question.
Yes.
In the test, like if you asked us this question, would we have to draw all 3 graphs or just the
Yes.
final?
Yes, yes. The graphs will help you to find the answer. Because if you trying to think for this, maybe you would get like small mistake and you will lose some points for like the best thing is to graph, is the easiest way to graph to see where is the intersection exactly. Okay, Eric. What will be direction here? Do we have to mention it too? What do you mean for the direction? What will be direction here? Which direction?
Like from where this graph is going to be from 2 to 3 or 3 to 2?
From 2 to 3.
Okay, because it's a close, that's why. So it's going to open
No,
direction.
you have to start in the left. You start by the small number. To the right is the large number. In all
Okay.
intervals, yes.
Oh, thank
In
you.
all intervals. In the left, small the small number. The right is the large number.
Okay, thank you.
Not because it close and open. I mean for small and large number. Now the same question, but instead of union, we're going to use. Instead of intersect, we're going to use union. So the same question, but instead of intersect, is union. So the question is a graph is from 2 to 3. Let me write it again. From 2, 3. At 3 is open. So same example. Graph the set 1, 3 open, union 2, 7. So the same idea, we have to graph the first one, first line, Second line, here the union means I'm not going to graph the first one and second one. So by using the previous question, I'm going to graph only the solution because I have the first one, I have the second one, the green one. So I'm going to graph the solution by using the first one and the second one. In the exam, you have to graph the first one, the second one, and the third one, the answer. So
Professor,
here,
what
yes,
does
yes.
the n mean again? In the
What is
middle.
that?
What does
this is
the n mean again?
This is union.
Yeah. I
This
know
is
the U means union, but the first one, graph the set 1, 3, and in the
intersect.
middle.
Intersect.
Intercept? And
Yeah,
then
this is intersect.
okay,
Or
thank you.
intersection. Yeah, intersection. Here is the union. So here it's reading, if you need to read it, is the open circle intersect the close, the open interval intersect the close interval. Here is the open interval union the close interval. So for the third one, the union, as I said before, it's all values in A and in both of A and B. So here is the values from 1 to 3. So first things you have to graph the from 1 to 3 like this. I'm going to use this color. So you go down like this at 1, open circle, graph from 1 to 3 in this line. Here is the 1 and here is the 3. Graph this one first. Then you graph the second one, the green one, above of this one. So when you graph the second one above this one, I get 2 here, be closed. And all line, so number 3 will be closed. Why? Because the second one in the top of the first one will close the number 3 to the 7. 7 here is close. So all values will look like this. So it will look like all values from 1, closing everything, to number 7. So if I need to graph this one again as a final answer, will be from 1, here's 1 to 7. Here's 7. So at 1, at 1 is open circle. At 1 is open circle, open. And at 7 is a closed circle. And there is a line between this 2 points. Here's the line. So this is the graph of 1, 3, 1, 3, union 2, 7. The answer is the open interval from 1 up to 7. At 7 is closed. Okay. Can you please give me the link for what? Link for what?
Oh, it's not for you. It's our little group to get help.
Professor. Thank you.
Okay. Anyone has a question for the graph, the set? So this is the union, and above this is the intersection. So again, one.
I'm sorry, I have a question.
What's your question?
Give me a second.
Yes, go ahead.
When we wrote when we previously on the previous slide, when you had S.
The previous one, hold on one second. Here it is, yes.
Yeah, when you had S union T, you listed out all the values.
Yes. So
I was just wondering.
Yes, I listed up all the values in S, 1, 2, 3, 4, 5. Then I go to the values of t is 4, 5, 6, 7. So I put 4, but 4 is already inside the set. So I don't have to write it again. 5 is already inside. The 6 is not inside, so I have to write it down, and the 7.
Okay. I was just wondering why it was a bit different when it came to the graph. Like, what makes this?
No,
Why
this is,
couldn't we?
yeah, this is for sets, and the graphs is for intervals. So this is sets. In set, they give you like certain numbers. They not give you infinity numbers. For intervals, they give you all values from 1 to 5 with a fraction, and with the rational numbers, with irrational numbers. This is mean for interval. So the interval is more bigger than set. The set, they give you just certain numbers, 1, 2, 3, 4, 5. For interval, they give you like a huge number, all numbers from 2 to 5, for example. I mean, like
So wait,
2.1, 2.2, 2.3.
just to clarify, you're saying that when you have, like, for example, 1,7, you're saying all numbers
Yes, yes,
including the ones in the middle of 1 through 7.
yes.
Okay, got you. Thank you.
Here we don't have to graph. Therefore, interval only, we graph. Okay, any question for this one? Make sense? Okay. Example for this one. Hold on 1 second. Okay, so here. Example look like this. Three over 5 like this, minus 3 over 5 divided by 4. How we can do something like this? Okay, let me write it again. So I have two fractions. First fraction, second fraction. First fraction, we have 3 over 5. Second, we have subtraction, and subtract 3 over 5 here over 4. Who will do this one? Any idea?
So you can write out the fraction like 3 over 1 times 5 over 3 by the reciprocal.
Okay,
So that,
nice.
15 over 3, which is 5. 5 minus, I don't have a pen and a pencil. Hold on, I'm doing it in my head.
Yeah, this is
So
nice.
this one is
So let
5.
me do it with you step by step.
Sure.
So here is a 3 dividing by this one. Like I said, when you divide, when you see something like that, so if this is equal 3 over 1, like this is 3 over 1, dividing of 3 over 5, if I want to write it again, minus 3 over 5 dividing by 1 over 4. So to do this one, like he said, what's your name?
No, Ole, if you do that, it's gonna be 4 over 1. You didn't change it yet.
Oh yeah, I did not change it because I changed everything.
No,
I
no, no.
rewrite it again. I
In the
rewrite it
second-
again. This is dividing. I put it like the division sign here. See
No,
what I did?
I'm saying you see how you wrote 1/4? It should be 4 over 1 because you didn't change. It's gonna be
Yeah,
1/4.
yeah. I'm going to change right now. So this is equal to 3 over 1 times, we flip this one, 5 over 3. This is correct. Minus 2 over 5, the same like this. Cross multiply. We flip the second one. Give me 4 over 1. Okay.
No, it's gonna be 1/4. Because you see, you when you write 1/4, it should be 4/1, and then when you change it, it's going to be 1/4.
Now this is 3/5. I keep it the same like in numerator, dividing by the denominator. Oh,
No.
okay, hold on. Yes, exactly, correct. Sorry for that. This is correct. Thank you. Yes. Sorry for that.
And now it's
So-
going to be 1/4 when you change it.
Yes, this is correct. Thank you. So here's 1/4, 1/4. So what's the answer now? We can cancel the 3 with the 3. Can we cancel the 3 with the 3?
Yeah,
Yes.
you can.
Okay. And what about the 2 with the 4?
It's going to be 2
2. Exactly.
and 1 instead of 2.
Yes.
Professor,
Or
it's
you don't
3,
have
I guess.
Five.
Like 3 by 5.
With the 3 with the 5? Which one?
No, for the 2/5, it's supposed to be 3/5. You put 2/5 instead of
Three
3.
over 3.
The second one.
Second one.
Yeah, you
Three-
put 2.
3/5 multiplying by 1/4. Now we cannot divide 4 with 3. So now I get 5 minus 3/20. 3 because 3 times 1 and 5 times 4 is 20. Now we have, because we have fraction here over 1, so we have to do cross multiply like we learned last time, right?
Wait, no, we need a common denominator, no?
Or the common denominator. We can do cross multiply, or we can finding the common denominator. Here, the common denominator here we have to multiply by what?
By 5.
20.
By 20
20.
times both sides,
Yes.
yes.
So I get 20 times 5, 100 over 20 minus 3,
You put 2.
20 over 3 minus over 20. So now I get 100 minus 7 is
97.
97 over 20. Any question for this one? Is it clear what we did
What?
here?
Yeah, I'm kind of confused. Why do you multiply by 20?
Why we have to multiply? Oh, okay, because like last time I said, we can do cross multiply by multiplying 5 by 20 and 3 by 1, and we're doing like last time, or we're looking for the common denominator. So we cannot like subtract 5 minus 3 over 20. We have to, because the 5 is actually 5/1, so we have to make the denominator are equal. So I multiply both sides here by 20, the numerator and denominator. I get the same denominator now. So I get here 20 times 5, they give me 100 over 20 times 1 is 20 minus the same fraction here, 3/20. So the denominator are now equal. So this is good. Just we subtract the, the denominator are equal. Now just we subtract the numerator. 100 minus 3 is 97 over the same denominator is 20.
Oh, I get it now.
Okay. Or we can do the cross multiply like we learned last class, 5 times 20, 1 minus times 3, but will be like more, or you can do this one is easier.
Where did you get the 5/1 from?
5/1 from here, because the 3 with the 3, they cancel each other, so I get 1. I get here 1. And here is 1. So I multiply 1 times 5, they give me 5, and 1 times 1, they give me 1. Again, 1 times 5, they give me 5, and 1 times 1, they give 1.
Oh, okay.
Clear?
Yeah.
Okay. Now let's go to the exponent and radicals. Any question before we move? Okay. So here,
I'm sorry, can you just go back real quick?
yes, okay.
Thank you.
So here is a new section B.3 is called exponent. And radicals. No, it's called, hold on. Integer exponent, not any exponent, integer exponent and radicals. Integer exponents and the radicals it's in the next section. So just integer exponent. Next section will be radicals. Okay. So here in this section, we have to know if for example, I want a product identical numbers, for example, like 5 times 5 times 5 3 times. This is, I can write it as 5 to the power 3. Here's our identical number multiplying to each other. So here is, I can set identical numbers or identical number, where I can set a product of identical numbers. So when I multiply, for example, 6 times 6 times 6, they give me the same things, 6 to the power 3. I can write it as 6 to the power 3. So in general, I can say if A is a real number, so I can say here in general, if I have A is real number, and I have N is positive number, I mean like not any number, positive integer, then I can define the nth power of A, the nth power of A is written as A to the power N is something like that. 1 second. Is A to the power N equal A times A to the power N equal A times A times dot 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 times A. I mean for dot dot is N factor. N factor. For example, like here for this example, 5 to the power 3, this is mean I have to multiply 3 times the 5. So 5 times 5 times 5. The N is 3 factor. So I don't need this one. Okay. Now A here is called base. This A called base. And N is called exponent. Exponent. Let me give you a small example. So can I move to the next slide? No. Okay. So, for example, what is the value for 1/2 to the power 5? We'll do this one.
So if you want to break it down, it's 1/2 times 1/2 times 1/2 times 1/2 times 1/2.
How many times?
5 times.
Exactly. 1, 2, 3, 4, 5. And what does that equal?
That's 4, 8, 16, 1/32.
Okay, exactly. So we multiply the numerator together. 1 times 1 times 1 times 1 times 1. They give me 1. And 2 times 2 times 2 times 2 times 2. They give me 32.
Or you
Because
could have
2,
done it.
yes,
You could have
go
put,
ahead.
you see how 1/2 is under the bracket and exponent is on the top. You could have literally just put 1/5 and then 2/5. That's also 1/32.
This
I mean,
is
that's
correct. Yeah, this is correct, but we do not use, we do not take the properties yet. This is
okay.
correct. I'm going to talk about this property and we're going to use it. Thank you. Okay, what about this example? Second example, this is example A1. Number 2B, -3 to the power 4. Who will do this one?
So it's just -3 times 4 times.
-3, 4 times. Second time, third time, times the fourth time. So what is the answer now? So I get -3 times -3, they give me 9 because negative times negative positive. 3 times 3 is 9. And the same things here, -3 times -3, they give me 9. So 9 times 9 is 81 positive. So the answer is 81 positive.
It's like, for example, if the base is negative and the exponent is an even number, it's always positive.
This is correct. But we're going to talk about this also later. That's 100% correct. Now, number C. If I have -3 to the power 4, what does that equal? We'll do this one.
Isn't it the same as the one up?
Is the same,
Oh.
like what I have to do. It's not the same. This is not the same like this one.
Really?
Yes.
I think the -9.
It's
No,
because
it's not.
it's because the negative is not included now.
Exactly. The negative is not with the power. The negative is not with the power.
The
So,
negative, yeah, go ahead.
yeah. So yeah, go ahead, Iman.
Okay,
What's your
so
name? How you pronounce your name?
Iman.
Iman. Okay, go ahead.
Yeah. So you see, when it's a parentheses, that means the negative is included with the 3. Right now, the negative is by itself. You can think of it as a -1. You can think of it as a -1, and then you can say parentheses 3 to the 4. So that's
Exactly.
81, but then you have a -1. You have to multiply it later. So that's -81.
Oh,
Nice.
so we put the negative sign aside and we do the 3 raised to the power 4 and then we add the negative sign? Basically?
Yes.
Okay.
Yes. So look what we have to do. We have to write down negative outside like this, open parentheses, big one, and you have to multiply the 3 4 times. 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 27, times 3 is 81. And after that, this is inside the parentheses 81 times the negative, they give me -81. So now the second one and the third one is not the same. So I can set here -3 to the power 4 is not the same as -3 to the power 4. Why? Because in the first one, they gave me positive 81. And the second one, they gave me negative 81. Different answer. Okay, any question for this? So let's go to the 0 and negative exponent. So here, 0 and negative exponent. So the 0 and negative exponent. So what is that said here? If this property says if I have a, this is real number not equals 0, and I have n, and n is positive integer, then a to the power 0 always give me 1. Any real number, this real number is not equal 0, to the power 0 they give me 1, always. And I have to know a to the power minus n, this is equal 1 to the power a to the n. Again, a to the power minus n, this is equal 1 over a to the n.
Sorry, we
Any,
can't read what you're writing
yeah,
down.
here I get anything power to the 0 is 1. Yes, anything power to the 0 is 1. But this, not anything, I mean any real numbers is not 0. Here a is not 0. I mean all real numbers except the 0 to the power 0, they give me 1. Yes, go ahead. Who asked? Who
Oh,
has
I
a
was
question?
saying we can't really see what you're writing like at the bottom of the page.
Oh, you cannot? Okay, so I'm going to write it again. And next slide. So here, a to the power 0, always they give me 1. But this a is not 0. And the second things you have to know, a to the power minus n is equal, we flip this one, a to the n, 1 over a to the n. Example. So suppose I have 4 to the power over 7, 4 over 7 to the power 0. What is that equal?
1.
1. Yes. Anything to the power 0 is 1. Exactly. Second one, x to the power minus 2.
1 over.
That's 1 over,
oh,
1
go ahead.
over x to the 2. And the negative becomes positive when you take it down.
Yes, this is correct. So we have to flip this one. So give me 1 over x to the power 2. Number 3, minus 2 to the power minus 3. What's that equal? Who will do this one?
I'll
Oh.
try.
Yes, go ahead.
So is it 1 over hold on, 1 over negative 2 raised to the power 3?
Yes.
The power is, yes.
Yeah.
So minus 2 with the parentheses to the power 3. And this is equal 1 to the power minus 2 times minus 2 times minus 2. They give me minus 8. and 1 over minus 8 is equal minus of the fraction 1 over 8. Any question for this examples? No questions? Okay, now I'm going to give you rules for the exponent. Some very nice rules about exponent. So here is rules for exponents. What's the answer for the last question? Hold on. The question is find the values for each of. Here, find the value for each of following. Here, find the value for each of the following. Ahmed,
No, I understand it. It's just I don't know where you put the negative on the,
this one,
yeah.
third one.
No, like do you put the negative next to the 8 or you put it in the side? You see how
Yes,
you
this is here. This is the same as the same like this one. The negative, I remove it from here. I brought it outside the fraction. This is the same.
oh okay.
Okay.
Yeah.
Here and here are the same things.
All right, thank you.
No problem. Rules of exponents. First rule says if I have a to the m times a to the n, so the bases are the same. I have two power numbers. This power number, this is a power number. They have the same base, a and a, with different exponent. This is equal a, the same base, and we just adding m to the n. We adding the exponent. Example, if I have 2 to the power 3 times 2 to the power 4, what is that equal? We just add the exponent 4 plus 3, 7. Because we have the same base. Okay. If the bases are the same, just we added the exponent. And between of them are multiplication. If addition, this is not correct. If we multiplying two elements, two numbers, two power numbers, they have the same base with different exponent, we just add the exponent to the same base. Number two, if I have a to the m dividing of a to the n, this is like before, but we have to change. Instead of adding, we subtract the exponent. So we have the same base. This is equal a to the m minus n. Small example for this. 2 to the power 4 over 2 to the power 3. This is equal 2 to the power 4 minus 3. And this is equal 2 to the power 1. Here I can say this is equal 3 plus 4. And this is equal 2 to the power 7. Number 3. If I have a to the m, everything to the n, we just multiplying m with the n, the power m with the power n. So this is equal a to the m times n. Example If I have 2 to the power 3, everything to the power 2 or to the power 4, this is equal to 3 times 4, 12. 2 to the power 12. Number 4, if I have a times b, everything to the power n, we can distribute the exponent inside the parentheses. You give me a to the power n times b to the power n. Without here, I put it like a dot. A to the power n times b to the power n. Small example for that. 2 times 3, everything to the power 2. So I get 2 to the 2 times 3 to the 2. And this is give me 4 times 9. And this is 36. So the 36 is the same as this parentheses. We don't have to get the answer, but I show you here we don't need it, the answer, just to show you we can distribute inside, we just can distribute the exponent inside the parentheses. Here times. Another one, 5. A over b, everything to the power n. This is equal a to the n over b to the n. Example for this. Example. 2 over 3, everything to the power 4. This is equal 2 to the power 4 over 3 to the power 4. Number 6, a over b. This is very important one. Minus n. This is very important rule. Here the minus mean we have to flip inside the parentheses. So I get b over a, everything to the power n. And now we're using the previous rule, number 5. We're distributing the n inside the parentheses. I get b to the n equal a to the n. Example for this, 2 over 3, everything to the power, for example, minus 4. So the minus means we have to flip inside the parentheses. I get 3 over 2, everything to the power 4. Then we have to distribute the 4 inside the parentheses. I get 3 to the power 4 over 2 to the power 4. Any question before I move to the next slide? All of them clear? All the rules are clear? What about the other student?
Yes, it's clear.
Okay. It's clear. Okay. So we have the last one, the last rule. Last one is if I have 7, if I have a to the power minus n over a to the power minus m. This is equal, the minus goes down. We have to move this one, the numerator, I mean here b, sorry. Hold on. Here I have b. So we have to move the one in the numerator to the denominator. We have to move everything in the denominator to the numerator. Why? Because the minus. So here I get b to the power m positive, and here a to the power m n. So this is very important rule too. We're going to use it a lot. Example, 2 to the power minus 3 over 4 to the power minus 5. So this is equal. We have to move everything, like moving the numerator to the denominator and moving the denominator to numerator. So I get here 4 to the power 5 over 2 to the power 3. And that's it. Okay, examples for this. Is it clear, the last one, before we go to the example?
Yes.
Okay, so the examples is similar to the rules. Number one says simplify, not simplifying, by using the rules before, find each of the following: x to the power 4 times x to the power 7. What is that equal? Who will do this one?
I'll do it.
Yes, okay.
So x to the 4 plus 7.
4 plus 7. Why? Because by using the first properties, the first rules, if I have the same base, different exponent, we just adding the exponent. So the same things here, just we add the exponent. 4 plus 7, they give me x to the power 4 plus 7 is 11. Okay, number two. Y to the power 4 times y to the power minus 7. What is that equal?
So since it has a negative exponent, you flip it. So it's y to the 4 over 1,
Y to the 4 over 1.
I think.
Okay, what about if we use the same property number 1?
Oh, the same same
Yeah.
base. Sorry. So it's literally
Yes.
Y
Wow.
to the negative 3.
Yes, so we have the same base, y and y. This is mean we have to keep y, and we just adding the exponent 4 plus minus 7. So this is equal y of minus 7 plus 4, they give me minus 3. And what is that equal?
1 over y to the 3.
Exactly, by using property number 7. So this is equal, or the previous property, I mean, like the negative property, this one. A to the negative exponent, this is equal 1 over a to the n positive.
I mean, you can always remember it by saying like you can never leave an answer in a negative exponent.
Yes. But some question they ask you to write it in the negative exponent in the simplest way. So here I can write it as 1 over y to the power 3. Question number, example number 3 is x over 2, everything to the power 5. What is that equal? Who will do this one?
Oh, actually,
Yes, go. Yes, go ahead.
Me?
Yes.
Okay. X to the power 5 over 2 to the power 5.
X to the power 5 over 2 to the power 5. And how
Yeah.
we can simplify it? X to the power 5 over what? 2 to the power 5, what is that equal?
Mm,
We have to multiply 2 5 times to itself.
120. No, that's more.
Yeah, what I get? 2 times 2 times 2 times 2, 5 times.
Calculator time. Hold on. 5 times.
Isn't it 32?
Yes,
No.
32.
Yeah.
So 32, yes. So it's 32. Okay, now the last example in this section is simplifying. And this question, this example, you will see it a lot during the first exam. It's called simplifying. I'm going to moving to the next slide. Can you move? Did you take all these notes here?
Yeah.
Okay, I'm waiting. Yes? Okay, so simplifying. So the question is simplify each of the following. First one is 2 times a to the power 3, b to the power 2, multiplying for the other parentheses is 3a, b to the power 4, everything to the power 3. How I can starting doing this one?
We first have to distribute the exponent to the 3ab to the fourth, and then we multiply
Exactly.
2a cubed b squared by our new product of that.
Nice. Thank you. So first things we have to distribute the exponent here inside the parentheses. This is the first step. To the 3, to the a, I mean, to the 3, to the a, and to the 4. This is the first step. So let me write it down. 2a to the power 3, b to the power 2 times a 3 to the power 3, because after I distribute it, a to the power 3 and b to the power 4, everything to the power 3. Now let me simplify it again, but during simplifying I prefer to combine numbers together and combining the same letters to each other. I mean, for that, I have to multiply the numbers together. I get here 2 times 3 to the power 3. 3 to the power 3, they give me 3 times 3 times 3 is 27. So here is 27. So we're combining numbers together. Then combining same together, I mean like a to the power 3 times a to the power 3 again. And the last one is b. So I get b to the power 2 times here b to the power 4, everything to the power 3 is b to the power 4 times 3. They give me b to the power 12. So here is b to the power 12. Now let's simplify it more. So I get here 2 times 27. They give me 50, 54. For the a's here, because we have the same base, so just we add the exponent. So what I get, a to the power what? Eric, that's correct. To the power 6, because 3 plus 3, they give me 6. And the last one is b to the power 14, because 2 times 12, they give 14. Yes, this is correct. So 54 times a to the power 6 times to the power b to the power 14. This is the final answer. Any question for this? Okay, so number B now. Let's do B in the same page, slide I mean. So here B, So is x over y, x over y to the power 3 times y square times the x over z everything to the power 4. So like the previous one, we have to distribute everything inside the parentheses. So who will help me to do this one? Who will help?
I think we should start with the first one.
Yes, the first
So
parentheses.
x raised to the power 3 over y raised to the power 3.
Yes. So we're distributing the 3 inside the parentheses. X to the power 3 over y to the power 3. This is the property here. This one. Number 5. A over b, everything to the n is a to the n, b to the n. Again here, multiplying by the second parentheses, we're distributing the 4 inside, so I get y to the power 2 times 4. Y to everything to the power 4. X to the power 4. Everything to the power 4, z to the power 4. Now let's combining the same variables, I mean the same letters to each other. So I get here x. Oh, before I combining, let me simplifying and multiplying the numerator together and the denominator together. I make it one fraction. So this is equal x to the power 3 times y to the power 8, because we multiply 2 to the 4, they give me 8, times x to the power 4. Everything over y to the power 3 times z to the power 4. Now let's combining the x together, the y together, and the z together. So I get equal here. This is equal here. X to the power 3 times x to the power 4 times the green color, the y to the power 8 over y to the power 3, because this is in the denominator. And the last one is z. So the z will be something like this here. 1 over z to the power 4. Now let's combine everything, make it more simple. Here I have x to the power 3 times x to the power 4. We're just adding the exponent because the bases are the same. So x to the power 7 times here the y to the power 8, and in the denominator y to the power 3, I can combining together because they have the same base. So I just subtract here. They give me y to the power 8 minus 3 is 5. And in the last one, I have to move because sometimes they told you don't write the question, don't write the answer as a fraction. So you have to move the z to the power 4 up to the numerator. So when you're moving this one from the denominator to the numerator, just you have to change the sign. So I get here z to the power minus 4, and that's it. This is the final answer. Any question?
Yes, I kind of have a question.
What's your
So
question?
what if could the answer have been like x to the power 7 times y to the power 5 all over z to the power 4?
Yeah, I got that answer as well.
Yeah, this is correct.
Okay. Both of
Both
them?
both of them correct.
Okay, thank you.
Yeah, sometimes when the question told you don't write the answer as a fraction, you have to write it like in this way, like this. But if they told you did not like specify an example what you have to do, You can write it as x to the power 7 times y to the power 5. All of this over z to the power 4. This is correct too. Now, the last example. We have 2 examples more, I mean.
Professor, could you explain one more time the example B?
Which one, B?
Yeah.
Okay, this is starting in the beginning. So we're distributing the 3 inside the parentheses. So x to the power 3 over y to the power 3. And the same things for the 4. We have to distribute everything at the power to the everything inside. Y to the power 2, everything to the 4, x to the 4, and z to the 4. Now we're multiplying the numerator together and the denominator together. I make it one fraction. So I get here x to the power 3 times y to the power 8. Why? Because y to the power 2, everything to the 4, they give 8 to the 8. Y to the 8 times x to the 4. I move it down. Same things here, y to the power 3 times z to the power 4. Now we're combining the letter each together, combining the x together, combining the y together, combining the z together. So x to the power 3 times z x to the power 4. This is combined together. Y to the power 8 over y to the power 3 together. And the z, this is the only one I have, is 1 over z to the power 4. Now, because I have the same base, x and x, so just we add the exponent, 3 plus 4, give me 7. And here the same things, I have the same base by using the properties before, like in the previous slide. 8 minus 3, they give me 5. And the last one here, by using the properties here, this one, this property, I have 1 over z to the power 4. I can move it up like this one. Just I have to change the sign. So I get here z to the power minus 4. And that's it. This is the answer for this question. Some students, they told me we can write it as x to the power 7 times y to the power 5, everything to the power z to the 4. This is correct too. Okay, example now. Here is the example. So the same things, simplify the expression. I have number 1, A, is 6s t to the power minus 4 over 2 times s to the power minus 2 times t to the power 2. Who will help me for doing this one? What I have to do first?
So first, you have to distribute the -4 of the exponent to all of the members of the group and the numerator.
Okay, so, but what if we're combining the numbers together first of all? Like, I mean 6 over 2.
Do you have to flip?
And what about we're flipping up the minus up?
Yeah,
So
we
we
have
can, I mean, like Aman, he can solve it in different way, and for me, I can solve it in another way, and the other student can solve it in another way. I mean, like always must give the same answer. So for my way, I just combining the numbers together, 6 over 2, and they flip everything in down variables to the up. So this is multiplying by s, multiplying by t to the power minus 4, multiplying by ts to the power 2 because I have to move this one up. So they give me s to the power 2. We change the sign from negative to positive. And for the last one is t to the power 2. When you move it from down in denominator to numerator, we have to change the sign again. You give me t to the power minus 2. Now let's combining the t together and the s together. So 6 over 2 is 3. And s together, s times s. And I have also t to the power minus 4 times t to the power minus 2. Here s to the power 2, sorry. Here's 2. S times s to the power 2. Yes. And t to the power minus 4 and t to the minus 2. Yes. So now the final answer is 3 times s to the power 2 plus 1. We have the same base, different exponent. We're just adding the exponent. S to the power 2 plus 1 is 3 times t. Here we have different exponent, the same base, minus 4 minus 2. You give me minus 6. And this is the answer.
Sir, I got something different.
What you got?
I got 3s to the 3 over t to the 6 over
Again,
t to the 6.
you get the same like this, s to the power 3 over
It's because,
like this.
I
This is
think-
correct. This is correct because here the negative exponent goes down, come positive. Okay, Aman?
I have a question.
Yes.
Can you know how you wrote the answer 3 times
It's
s?
because
I'm sorry. You know how you
Yes.
wrote 3 times s to the power 3 times t to the power 6? I wrote instead of t to the power 6, 1 over t to the power 6 as a fraction. Is that all right?
This is correct. Yes, this is correct too. Yes, it's correct.
Okay.
But you get the same answer, Ahmed? 3 times 3 s to the power 3 over t to the power 6. This is the
Yeah.
final answer. You get the same answer?
Yeah, I got that.
Okay, you are correct.
I have a question.
Okay, you're correct. Yes.
So you know how he got
What's
the
your
last
question?
person got 3 times s to the power 3 over t to the power 6. Can you do 3 times t to the negative 6 all over s to the negative 3?
Yes.
If that makes sense, like flip the s
Yes.
as a t.
Yeah, I know what you said. Like this, 3 times t to the power negative 6 over s to the power
Yeah.
minus 3. This is correct too.
Okay, got it.
Yeah.
Thank you.
But I don't like a negative exponent. I
Yeah.
prefer to make it like positive.
Mhm.
Positive is better than negative exponent. This is correct too. The last example is we have y over 3z to the power 3, everything to the power minus 2. What is that equal?
It equals. Wait. First of all, you're gonna flip the inside,
Which property would you like to use?
the sixth one.
6, 1, exactly. So flip and remove the negative. Okay, let's do it. So flip and we have to remove the negative. So I get, what I get?
You got 3z
3z to the power,
3
okay, over what?
y to the power. Wait, over
Yes.
y. Sorry.
And
Then
everything to the power 3, to the power 2, positive 2. So now I get, we distribute the 2 inside the parentheses. I distributing this one inside for numerator and for denominator. So I got 3 to the power 2 times z to the power 3, everything to the 2 over y to the power 2. 3 to the power 2 is 9 times z to the power 2 times 3 is 6, z to the power 6 over y to the power 2. I can simplify it more, this one. So this is equal again 9 times z to the power 6 times y to the power minus 2. This is correct, and this is correct here. Any question? Does it z to the power 3 does z to the power 3? What is tons? What do you mean tons? Tons into z to the power minus 3. Eric, tons? Turns, okay, turns into. Does the z to the power 3 turns into z to the power minus 3 in which one? Oh, okay, we have z here. Yeah, the z goes up and the 3 goes up and the y goes down. Here, everything is moving up and this goes down. So I get 3z to the power 3 and the y goes down y. Now we're distributing the 2 inside. Why I do this? Because the negative sign, you see the negative sign here, the negative exponent. I remove this negative. By flipping inside the parentheses. So I get here 3z to the power 3 over y, everything to the power 2. Now I distribute the 2 to everything inside the parentheses. So in the numerator and the denominator. So 3 to the power 2 times z to the power 3, everything to the power 2, and here y to the power 2. 3 to the power 2 is 9, z to the power 3 to the power 2 is give me 3 times 2, 6, over 3 y to the power 2. Now 9 times z to the power 6 times y to the power minus 2. But it's what is not z to the power minus 3? No, it's not to the power 3. When you, because the minus here inside, flip everything inside. Mohsina. So the minus this, flip everything inside. We don't have to change also the sign when you flip. Just you move this one up and this down. That's it. When you move this up, you don't have to change the sign. Just moving this up and this is down, and you remove this sign here, the negative sign. So you get only 2. Then you distribute the 2 inside the parentheses. Do we get partial credit in the exam? It depends. It depends on the question. Eman. It depends on the question. Eric, does z to the power 3 turns into z to the power minus 3? No, we don't have to turn it. Just we have to flip it. Any other questions? So by this section, by this example, we finish the section. And next time we're going to start for a new section. I'm going to post a new assignment with a sign is P.2 is the real numbers, and this section is the integer exponent. Okay, and have a good day, everyone, and have a nice day.
Professor, I have a question.
Yes, what's your question?
Do we get partial credit on the exam?
It depends on the question. It depends on the question of the exam.
Questions like these.